In this video, I'm going to break down resonance structures a little bit and hopefully help you wrap your head around it if you are struggling with it. So the first thing I want you to notice is that each of these resonance structures, that double bond is in a different location and has double-headed arrows in between them. Now, what I just want you to know before we get into it is that those double-headed arrows indicate the actual structure is a combination of these resonance structures. So let's get right into it. All right, we have some rules. As with every other thing that we do in chemistry, there are some rules to follow. So first rule, if a Lewis structure has a multiple bond, it will have a resonance structure. If you have a multiple bond, it will have a resonance structure. And that should calm your brain down a little bit while you're trying to figure out, well, how do I know if it has a resonance structure? Well, a multiple bond will tell you that. Okay, so the second rule I want you to make sure that you're following is the number of resonance structures are mostly dependent on how many elements the central atom is bonded with. So I say mostly because I typically don't like to use the words always and never in chemistry. Rules tend to change, and so I just want to say that resonance structures are mostly dependent on how many elements the central atom is actually bonded with. Now, third rule of thumb, resonance structures are represented with double arrows between them. I know I already told you that, but that's what those double arrows mean. So let's just jump into example one. I went ahead and drew this Lewis structure. We're working with NO2, and the reason I did that, if you're struggling with Lewis structures or anything like that, make sure you go to the video library and find that Lewis structure video. That should get you where you need to be. But this is a polyatomic ion, which is why you see the brackets and the charge. If you draw a polyatomic ion, it does not have the brackets and the negative charge or any charge that is there. It might be a positive charge. It might be a -3, whatever the case may be. That charge and those brackets have to be there to indicate that it's a polyatomic ion. If it's not there, it is an incorrect answer. So I do have a multiple bond. That means I'm going to have a resonance structure. I'm attached to two central atoms. That means that multiple bond can move either where it's at on the right side of that nitrogen or to the other side of that nitrogen. We're looking at this double bond right here. It can go right over to the left side. And when that happens, we're going to go ahead and draw our resonance structure. And it's the exact same thing. And I made sure I have my brackets and my charge up on the right-hand corner. And basically, this double-headed arrow indicates that this is a combination of the Lewis structure. It represents kind of a bond and a half. It can't be correct. Single bonds are longer than double bonds. So basically what that means is that we have a single bond and a double bond, and that's kind of going to equal a bond and a half, but we don't draw half bonds. And so we need both of these structures in order to have the correct Lewis structure for NO2. And that, again, is just going to interplay. I just wanted to show you real quick that interplays. They can move from the right to the left, left to the right, two outer atoms, two structures. So let's go on to the next one. I have an N2O. So same elements, but we're playing around with it a little bit. I know that I need 16 valence electrons. So I went ahead and drew some of this out for you. Now, the 16 valence electrons, those came from drawing Lewis structures. So if you're not understanding where these valence electrons or how I got this total valence electrons, be sure to check out that Lewis structure video in the video library. So what I really want to look at is that because I've got two double bonds, right? And I'm going to go ahead and have show you this way. That double bond can definitely move, and we're just putting all of our electrons, because even in these drawings, you have to put your electrons. They are necessary. So make sure you are putting your electrons. Now just notice my electrons changed. I don't have 2 on my left nitrogen. I'm sorry, I don't have 4 on my left nitrogen. I now have a triple bond, and then I have 2 on my left nitrogen. So let's keep going, because we know that we can move that triple bond around. So we know we're going to have another structure, right? So if we have another structure, we're basically just moving that bond right over, just like we talked about before. Okay, so we make sure that we are following the octet rule. If you're confused about octet or the exceptions to octets, make sure you check out the octet video, the octet rule video. So one more example will get us where we need to be. Let's just look at what we had on the opening. So we have NO3. NO3 is a polyatomic ion. That's why you see it in brackets with a charge. If it's not a polyatomic ion, you will not be using brackets and a charge. So I just want to show you, this is the exact same thing we had in the opening slide, but I want to make you aware of what's happening. That double bond is moving in several different directions. So pointing out, we have a nitrogen is bonded to 3 outer atoms. If you look, we have 3 structures, and our double bond is just moving around from one oxygen to another. So if you are struggling with any of this, let's make sure that I'm showing you exactly what I'm talking about. I just want to throw it out here because we have structure number 1, of course, structure number 2, we have our double bond, right? And then we have structure number 3, and what's happening in that double bond is it's just moving, and it's just bouncing around, and it can go to the right or to the left. So if you have any questions, make sure you're reaching out to your instructor. We can help you try to wrap your head around these resonance structures, and hopefully this video has helped you.